Okay, Assalamualaikum and a very good morning to all of you. Nampak tak?
Waalaikumsalam. Nampak.
Oh. Okay. 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 By the way, I'm Dr. Muhammad Zuhairi Sulaiman, and I'm going to teach you chapter 4 and chapter 5. Okay. I guess some of you already know me lah, but some of you still didn't know. So my name is Dr. Muhammad Zuhairi, and I have been teaching fluid mechanics I think in UMP for around 13 years lah, 12 to 13 years lah in UMP. Okay, my specialization is thermal fluid lah. So thermodynamics, and previously I teach also applied thermodynamics and also heat transfer lah. And then I think Dr. Ahmed already finished chapter 3, right, before? So for your information, the final consists of 5 questions, and the chapter 4 and chapter 5 is half of the marks for the final lah. So means that around if 100, 55 is from chapter 4 and chapter 5. Okay, so so this is also important chapter for you in order to score the subject lah. And then for the chapter 3, around 20 marks. So 55 plus 20, so you got 75 lah. And then we have theory, theory for the fluid mechanics, chapter 3, chapter 4 and chapter 5. Theoretical means that no calculation lah. It is regarding the understanding. Okay. Okay. So for today, there are 2 sections right now, which is section 1 and also section 3. Yeah. So I guess for the section 1, you got only 1 hour, correct? Is it correct?
Yes.
Those who from section 1. Any of you from section 1 got class after 10? Ada kelas tak? Any? I'm not sure because previously during Dr. Aziz's class, section 1 got different time kan? So which is Wednesday night, I guess, for the 1 hour class. Is it correct?
Yes, sir.
Okay, before we proceed, do you want to stick to the Dr. Aziz time, or you want to, because that one is Wednesday night, right? Is it okay if we follow Dr. Aziz schedule?
Yes, sir.
Okay, sir.
Okay,
Okay.
sir. No
Because
problem.
actually I don't have time to set up back lah, because Dr. Ahmed combine section 1 and 3 right for the chapter 3, but previously separate chapter section 1 is a Wednesday night. So for the next week, I'm going to change your schedule for the section 1 to the Wednesday night. Is it okay? So means
Okay.
that section 3 today from 9 to 11. So section 3, you are your time is 9 to 11, right? Okay.
Yes, sir.
So because it is really difficult to manage if one class got 1 hour and another class is got already got 2 hours lah. Okay, so I hope that you can accept that decision. So we fix the schedule as we discussed just now lah. Okay, so we're going to go to the chapter 4. Okay, so chapter 4 is regarding pump and the system lah, system. So actually, in the slide, as you can see, the blue device is one of the example of the pump lah. One example of a centrifugal pump. Okay, so so for this chapter, before we start lah, so please see the picture over here. If you still did not know what is the pump, so this is the pump looks like lah. So as you can see here, this is the normal pump that we use for our house. And then the upper side is the common that we use in the industrial scale, industrial application. So what is the difference? Of course, for the industrial, it is the size is very big compared to the household appliance. So the one that you see right now is example of the pump lah. Okay, so for the pump, what is the thing that we need from you to understand at the end of the class? So below here is the objective that we list. Hopefully at the end of the class, you will able to understand the basic principle of pump operation lah. So we know that what is the purpose of the pump. Before that, you have to know what is the component in the pump lah. So you have several component, which is later we are going to discuss in detail. So after you know the component, you need to the second thing is you need to calculate and analyze the performance of a centrifugal pump lah. So during the analysis, you can use velocity triangle to check their velocity vector. So I guess some of you before learn about the vector. What is a vector? In mathematics, you learn that the vector have a magnitude of the velocity, for example, and then it also have the direction. So this is the tool that you use to analyze and calculate the pump performance lah. Okay, so normally there are many purpose for the second objective. For example, if you are going to be an engineer, design engineer for pump. So if you want to design a pump, so you need to know the fundamental lah. So later we will see what is the engineering parameters. Engineering parameters. Apa parameter engineering yang penting, very important for the pump lah. Okay, and then the next one is okay, you know how to determine and analyze performance of the pump and system configuration. Okay, after you have a pump, for example, you are going to install the pump into the system. So you have many system. You have, for example, piping system. Okay, and then you have many what we call it component for the piping system, which is contributed to the losses lah. So of course, for the pipe flow, you have losses because you have some friction inside the pipe. I guess previously you learned about the head loss, head loss, HL, correct? You have two types of head loss. Okay, dah pernah belajar kan head loss?
So can you record the meeting so we can revise it later?
Pardon, I cannot hear your voice properly.
Yeah, can you record the meeting?
Pardon?
Can you record it so we can revise it later?
Okay,
can you record it?
Okay, actually this one is the one that I'm going to recall after this lah. So I know you study sometimes for the sake of exam kan, but it is important to it's not only for the exam, you have to remember lah, because after this you are going to become an engineer. So of course, an engineer needs some fundamental basic lah that still remain in your head lah, and otherwise you still didn't understand lah. By the way, previously you learned about the internal flow. Internal flow means that the flow in pipes. So of course in the pipes you have the length of the pipes. So the pipe can be very long, can be very short, and so on. And of course there is a losses inside the pipe, inside the pipe. So that losses contributed to we denote the losses as head loss, can be major and also can be minor lah. So major is represented by the friction factor, and the minor can be from the bending, and also sometimes not commonly valve lah, valve and also bending. So from there you calculate your summation of head loss. So this is the thing that we are going to cover in the chapter 3. So you have the pump. So you want to calculate what is the losses inside your pipeline, and then you need to select suitable pump. Before you select the pump, you need to know the condition of the system configuration. So in this case, it is a piping system. Piping system. It's not only piping system. You have a valve. You have bending in the pipes. As you can see here, ada bending. So you can see here bending. There are many bending over there. So in the analysis, you need to calculate all the bending and also the valve, the valves involved. Okay, and then the objective number 4 is to analyze the pump system. Okay, based on the dimensional analysis, dimensional analysis and similarity law. So actually, the pump has many sizes. Pump got many sizes. So the shape of the pump normally similar if one factory fabricate a pump. For example, this pump lah. So there are many size. So the size depend on the blade diameter, blade or impeller diameter, impeller diameter. So for example, this one is a small blade. So for the industrial purpose, you have a bigger blade. So in order to investigate the performance, you need to know the dimensional analysis for the pump lah. So this one we will cover after this lah. Okay. Okay. So for the pump, actually the pump is a subset of a very big category that we call it turbo machinery. Turbo machinery. So when we talk about turbo machine or turbo machinery, so all the people will assume it is a pump, it is included compressor, it is included turbine. So this is the device that categorized under turbo machinery. So in our study right now, we are going to learn pump for the chapter 4, and after this, we are going to learn turbine in the chapter 5. Okay. So as you can see here, for the pump, it is divided into many types. So in this case, you are given 2 types, which is a positive displacement and also the dynamics pump. So what is the difference? Positive displacement is you got the changes in the volume. You have the changes in volume. But for the dynamic pump, you have a control volume. So you have control volume. So your volume is fixed lah. So in your study, we are going to learn this centrifugal pump. Of course, we have many types, which is axial and also mixed flow. But in your case, we are going to focus on the centrifugal pump. Why? Because it is widely used in the industry and also household application. Okay, so for the compressor, actually, to tell the truth, it is a subsection of pump lah, a subsection of pump. But in this chart, it is also a part of turbomachinery lah. Okay, and then the same goes to the turbine, which is positive displacement and also dynamic turbine. Okay, so you have a radial turbine, axial turbine, and mixed flow. So for the chapter 5, you are going to learn also regarding the radial turbine lah, radial turbine. Okay, so okay, any questions so far? Okay, before we start, I'm going to give a revision regarding pump lah. Because your friend said just now you need to do some revision lah kan? Ke kamu nak sambung terus? Okay. So in this case, I'm going to give you a basic explanation regarding the theory lah, regarding the theory. So let me have some space for the writing lah. Okay. So actually, for the revision, you should know what is the, we call it okay. So for the revision, you need to know the first one is energy equation. Okay. So the energy equation is given by Q heat. Q is heat in input plus work net. What is net? Equal to the changes of the energy in the system okay, so this is the changes in energy, okay, over time. This one is heat in, which is the net heat. This is the net work. Okay. Kejap saya ada call pula. Okay, sorry ada gangguan sikit. Okay, nampak tak?
Nampak saya nampak.
Okay, sorry. Yeah. Okay. So before you start studying pump, you need to know this one lah. This is the energy equation lah. Okay, so okay, daripada situ, so you have Q net in plus W net in. So you have two kind of work. In this case, W dot shaft net in plus W dot pressure net in equal to D system. Okay, oh sorry, this one is over dt. Okay, so from there, so we have this form. Okay, summation of the energy out m dot h plus v square over 2 plus g z. Okay, this one is out minus summation of the energy in kh plus v square over 2 plus g z. Okay, so I'm going to ask you before this, have you heard what is the Bernoulli equation? I guess all of you already know this one. Okay, so this is the basis for the Bernoulli equation. So normally for the Bernoulli equation, you have already assumed there is no changes in the Q equal to 0, and in some cases changes of the work equal to 0 before this, right? And then you have only this formula. You have only this formula. So for today, the revision is we are going to use this kind of formula very frequent in this chapter. So at the end of the okay, this is the form, but for the fluid mechanics, so normally we assume delta Q is equal to 0 because you are not studying the heat transfer, kan? But for the delta W is not equal to 0 because you have right now the work from the shaft. The shaft is related to the pump. Related to the pump. Okay. So to make it simple, so I have simplified form of the equation. So which is P1 divided by rho 1 plus V1 square over 2 plus G Z1 equal to P2 over rho 2 plus V2 over 2 plus G Z2, and you have E mechanical loss. Okay. Okay. So this term is represented by E mechanical loss equal to E dot mechanical loss, okay, pump, okay, plus loss turbine. So I give you a general equation first. Later we eliminate lah, the one that not included in our analysis. Okay. So this term, okay, is regarding the mechanical losses. Okay. So what is the mechanical losses? So it is contributed by pump, contributed by turbine, contributed by piping. So this is piping. Okay. So this is the summation of the mechanical losses lah. So in this case, if you study about pump, so normally there is no turbine lah. But for the piping, you have piping and then you have pump. For the case of chapter 5, so you don't have a pump, but you have the turbine. Okay, this is the thing that you are going to you have to remember lah. Okay. Okay, so next is I want to show you what is the difference in Bernoulli equation. So you have okay. So in our case, normally you see this symbol Q dot, which is equal to Q multiplied by M dot. So what is this? So this is this is heat. This is kilogram over second. This is the mass flow rate over 1 second. So this is the unit. This is the heat. Okay. So what is the unit for the heat? Q. It is W. What is W? Watt. Okay. Okay, boleh
Boleh, sir.
Okay. Sebenarnya saya banyak sikit ni. Okay. So for the Bernoulli theorem tadi, I want to touch a bit about the Bernoulli theorem. Bernoulli equation. Okay, you have this is the equation. So for this Bernoulli theorem, I excluded pump lah first. Just to make sure you understand this one. Okay, so for example, you have 2 points. For example, this is your pipe. So you have area at point 1, A1. So you have area at point 2. So this is point 2. So this is A2 lah. Okay, so here you have the flow in and here you have flow out. So you have the flow from here to this point. Okay, let's say this is level. This is second level. So this is dia punya height. Height in meter. Height in meter. Okay. So in this case, for example, you have the energy in this point demonstrated by this component. Okay. The energy at the first point here is represented by this component. Okay. So at this point, at one point, Okay, for example, point number one. So you have this energy, you have this energy, you have this energy. So this is, we call it pressure energy. So this is, we call it kinetics energy. This is we call it potential energy. Have you ever heard about this before? Pernah?
Pernah.
Pernah, but I think the one that you learned before is regarding the solid kan? Solid. I mean bola ke, something like solid from higher object to the lower. The object is at the higher level to the lower level kan? But this time we are dealing with the fluid. We are dealing with fluid. Okay. So normally when we deal with fluid, we use this density lah. Yeah. So before this, you learn or not this one wait a minute. Kinetics 1/2 mv square plus mgh. Correct? This one? Dah belajar tak? So this one is the thing that you learned before, but right now the same thing, but it is for the fluids. So when we talk about fluids, normally we use density, density. So for the solid, normally we use kilogram lah. We use this one, m, mass, we use mass. Okay, that's the only difference between physics for the solid and also this time is for the fluid. Okay, so when you this is also potential energy, this is also kinetic energy, this is also pressure energy. Okay, actually this one it is related to the internal energy, it is related to the enthalpy lah, enthalpy. Okay, enthalpy H equal to U plus P over rho. Enthalpy equal to H equal to U, internal energy. This is pressure. This is density. So actually for fluid mechanics, internal energy ni we have some assumption lah. So you only have pressure energy. So you replace in this form. Okay, this one is the one that you are going to learn in the thermodynamics. Okay, that one is not covered in the fluid mechanics. Okay, so in this study, you have to know various form. For example, this one is the first equation. So for the second equation, you might see the equation like this. Okay, so this time you multiply the first equation by the G. Betul G. So ini rho. Okay, you got this Betul? And then this one is equation number 2. So if you multiply again equation number 2 with rho, so you got P1 plus rho 1 square over 2 plus rho G Z1. So so you do the same for the right hand side. This one is left hand side. Okay, the same So I only want to show you there are 3 form, ada 3 jenis. It is only in the difference of the G and also the rho lah. Okay, boleh So that one is the basic thing that you have to know. And after that, we have to know what is flow rate. Since that this is the revision, so flow rate, there are 2 flow rate, which is the first one is mass flow rate. Okay, what is the symbol? M dot equal to kilogram per second, right? So m dot is equal to rho V A. So rho is density, V is velocity, A is the area. Okay, so I want to recall back. Okay, this is the point number 1. This is point number 2. So you have here m dot 1. So here is m dot 2. For the fluid, we know that fluid have two types, which is the first one is gas, and the second one is liquid. So the gas, in some cases, for example, chapter 3, you have incompressible, and then you have also compressible. So incompressible, the changes in the density is not is equal to 0. Means that rho 2 minus rho 1 is equal to 0. So this one is delta rho equal to 0. But in the case of the compressible, so the delta rho is not equal to 0. So means that you have the difference lah. For the liquid, you can assume the delta rho is equal to 0 because the density is not changes, or in some cases you can say it is negligible. Kecil sangat, negligible lah. So in our case, we have m1 equal to m2. So we refer back this equation, m dot 1 equal to m dot 2. So you have a rho 1 v1a a1 equal to rho 2 v2a a2. So this is area at the point number 2. This is area at point number 1. So in this case, you know that the rho is similar kan? Rho 2 is similar to the rho 1. So you got only 1 equal to v2a a2. So in this case, what is this? This is, we call it Q or V dot. So what is V dot? So you have a volume flow rate. Okay, this is the fundamental. So this is the revision. So V dot equal to kilogram volume meter cubic over second. So here you have your Q equal to VA. So VA is equal to what? Meter per second multiplied by meter square kan? And then you got M power of 3 over S kan? So is it the same? So you got the same. So that's why when you see this Q, it is equal to V dot. It is equal to VA. So V is velocity. This one is area. Okay, jelas slow sangat ni. Okay, so after that, boleh
Boleh.
Ni fundamental
Boleh
ni.
share.
Okay, harap-harap boleh lah. Okay, so after you pandai benda lah tu. Okay, so this one is general. So efficiency. Okay, efficiency. So we have pump, and also we have turbine. We have turbine. So pump, dia punya efficiency adalah equal to delta E dot mechanical of fluid divided by shaft in equal to W dot pump. Okay, ni tricky. So later I explain. Okay, so for the turbine, so this one is efficiency pump. This one is efficiency T, turbine. This one saya akan explain lagi lah selepas ni. This one saya tulis dulu Okay, fluid. Okay, so what is U? U is useful. This one is extracted. Okay, okay this one wait Okay, so this one you have W. What is it mean? It is small w multiplied by m dot lah. So this one is specific work. This one is work. This one is work per unit time. Okay, per unit time. What is the unit time? 1 second per second. Okay, so here later you will go in detail about this. So this is the useful, later useful, and this one is theoretical. Yeah, saya check. So this one later saya akan explain in detail lah. Ni hari ni just revision untuk chapter ni, untuk apa yang akan datang dan yang lepas lah. Okay, so before we go further, let me explain to you what is the purpose of the pump. Okay, so the pump is okay. The purpose of the pump is to supply energy to the fluid. To supply the energy to the fluid. So this is schematic diagram lah. Diagram. Okay. So you have here inlet, and then you have here outlet. Outlet. So the flow direction is from left hand side to the right hand side. So you have energy at the inlet and you have energy at the outlet. Okay. So when you supply the energy, which is in this case, you supply the energy which is from the work of shaft. Okay. And then of course you got higher energy out. So for the pump, originally the energy is from the electric, and then converted to the energy mechanical, and then convert to the energy by pressure. So energy by pressure. So what is the energy by pressure? So before this, have you learned about this? Delta P equal to delta H G H ataupun rho G delta H. Pernah jumpa tak this one? Have you ever seen this formula before? So this is pressure difference. Okay, so it can be like this, P2 minus P1 equal to rho G H2 minus H1. Okay, this is before this you learn about height, right? Ketinggian, height. But this time it's not only regarding the height, it is the one that we call it height. So before this, during your school, normally you said H is regarding the height, ketinggian. But now you have to convert this height to the height. The unit stay the same. The height is in meter. The height is in meter. Okay? Boleh? Understand? So in this case, electric, you convert to the rotating impeller, rotating shaft, mechanical energy, and then convert to the pressure energy. For the turbine, you get the energy from the higher reservoir macam dam ataupun empangan tu. Kemudian that kind of pressure energy, this one potential energy, it goes to the turbine, and then you got the electric. It is reverse to the first description lah. Okay, boleh this one okay. Okay, so now I'm going to go deeper regarding the pump, regarding the pump itself. Okay, so you have this kind of built-in, which is you have the diameter of the pipe. Okay, the in is pipe diameter or pump diameter. So inlet diameter. Kemudian the same goes to the D out. Okay, pipe diameter or outlet diameter lah. Okay, so now you have two parameter. This one is a fixed parameter, and for the V in and also P in some cases can be different. So in this case, you have pressure in and also pressure out, and then you have V in and V out. So in order to understand the flow right now, so you have to do the fundamental equation that I just give to you just now before this. Okay, so for example, you have the first equation, you have M in equal to M out. So we know that the changes in the density equal to 0. So you have rho 1 V1 A1 equal to rho 2 V2 A2. So this one is already eliminated. So we know that the D out and D in for the pump, normally it is similar. So D in is similar as D out. Kamu punya pipe normally similar, inlet and outlet is similar. So if you have the similar diameter, of course your A in is equal to A out. So in this case, your area is also eliminated because your A in is equal to A out. So you got V1, okay, V1 equal to V2. So V1 equal to V2. So means that, so we have here V out is equal to V in. Okay, understand about that? So for the second thing, you have the pressure. Of course, the pressure normally is bigger because you apply the rotating shaft kat sini. It's like you are pushing the fluids. So normally the pressure before is lower than after the pump. So the delta pressure or P2 minus P1 normally is bigger than 0 lah. It's not the same lah because you input the work from shaft tadi. Okay, so that's why in this case P out should be bigger than P in. So P2 should be bigger than bawah ni dia lari bigger than P1. Okay, should be bigger than P1. Okay, so in general, energy pump add energy to fluid, increasing in fluid pressure. So the fluid pressure is increased lah. Okay, and then for the pump, normally we call it for the liquid, and for the gases, normally you can call fan, you can call blower, and also compressor. It's just the name. It's like Original category is pump, but nama panggilan dia different. Nama dia nama sebenar lain, but you call it different lah. For example, semua pump. Fan ni pun pump. Blower also pump. Compressor also pump. But normally for the gas, for the low pressure different, it is fan. Okay. For the medium, we call it blower. For the high delta P, it is compressor lah. Compressor. Okay, understand? Okay, for section 1, you can dismiss if you can, but you can stay if you want. Okay, so this one is very easy. You have two kind. The first one is positive displacement. This one is changes in V is not equal to 0. Maksudnya there is changes lah in the volume. Volume. So volume change, volume. So for the rotodynamics, normally we have a control volume, control volume. Okay, so changes in the V normally sama je, dia control volume. Okay. Okay, that's the different lah. So the one that we are going to study is rotodynamics, which is specific to the centrifugal pump. Okay, and then this is the example lah. So this positive displacement. Okay. Okay. So pump ni you delta V changing is not equal to 0. So valve jantung kamu pun is not equal to 0. Okay. Kat sini pun laluan ni dia berubah-ubah. Dia ada compression. So the same lah. Okay, for the dynamic machine, for the rotodynamics tadi, roto pusing, dynamics pergerakan pusingan, dynamics machine. This is example lah. Turbo fan. Okay. Okay, so this one is the one that I already discussed to you. V out is similar as V in, but the P out is different. So refer to the previous discussion. Yeah. Okay, so later this is the fundamental for the pump. Tadi just now is revision, but now is the fundamental for the pump. Okay. So before this, I already explained about the flow rate, and right now we are discussing about volume flow rate. Okay, what is the relation between V dot and also M dot? It is by this equation. Okay, so the unit for V dot is meter cube per second equal to kilogram per second, and you have density kilogram over meter cubic. Okay, so after that you cancel this one, so you got M cubic over S. So in your calculation, so please use this kind of method in order to make sure that your conversion is correct lah. If not, you got wrong answer lah. Okay, so right now this is the one that we obtain from Bernoulli equation. This is energy at the outlet. This is energy at the inlet. Okay. So energy in minus energy out. So you got the net heat. The net heat. So in this case, H ni, if you transfer this G to this side, for example, H equal to P over rho G plus V square over 2G plus Z out minus P over rho G plus V square over 2G plus Z in. You can multiply this one like this, rho GH. So this one is rho G. So you eliminate lah. So you got this one is rho, this G eliminate. So this one you got rho GZ lah. Okay. So that's how you want to change. And we know that rho GH before this it is rho GH equal to what? Delta P lah, pressure. Okay, delta P. Okay. So that's how you relate lah. But the present calculation, in the present calculation, this one is the net head of the pump. Okay. Why? Because we are dealing with this kind of pump. So this is a pump. Okay. So you have at the inlet. This is at the outlet. This is point number 2. This is point number 1. Okay. Normally the Z. This one later I will explain. The general equation is this one. Okay, so we use Bernoulli, and then what is head? Head is H. Head. As I said before this, you learn H is the height, but right now we change H to the head. Okay, so the unit still the same lah. Okay. Okay. So in this case, if you see for the pump right now, the figure over here, okay, this figure, so you have a pump here. This is a pump. Okay, and you have here point at the inlet, and you have here point at the outlet lah. Outlet. Normally, for the pump, you see here Z out and here Z in. Z out and Z in. Okay. Okay, so normally if the Z out minus Z in less than 1 meter, okay, we assume it is equal to 0 lah. Maksudnya no different in the potential energy. So no different in potential energy. So that's why okay, like this. That's why here you see you should have V out minus V in over 2G plus Z out minus Z in. So this is the actual formula from here. From here. Okay, this is the net head. Net head. But right now we know that V out is equal to V in kan. So here you have you cancel out this term and then you got 0. And then remember, if the pump normally the size of the pump is less than 1 meter lah. So the size of the pump normally less than 1 meter. So we assume no potential energy from inlet to the outlet of the pump. So in this case, we can assume Z out equal to Z in. Z out equal to Z in. Sama. So this one also eliminated lah. Before that, this one is equal to 0. Finally, you got only this term. So that's why I said before, during your childhood or your school time, so you use this one, P out, P in equal to rho G and H. Right, this one. So delta P is equal to rho G H, kan? Betul? So in your degree or diploma last time, right? Or during your physics time during the school. So this is the reason why. This is the reason why we use like that. Okay, we go to the next thing, which is water horsepower. Water horsepower. So water's power is okay, is the you have the flow rate lah. So inside this you have a v dot, right? V dot here, right? So you have v dot. So what is v dot? It is Q lah. Normally you say Q flow rate. V dot also flow rate. In some cases, this v dot can be also written as Q. So you can use this one lah. Q G Q H. Okay. So this is we call it water horsepower. Water horsepower. So water horsepower is already normally included friction, internal leakage, flow separation, and blade surfaces and turbulent dissipation lah. Apa panggil dissipate yang di turbulent tu. Dalam pump, normally inside the pump there is a turbulent lah. You have the vortices with vortices inside the pump. So there is losses in energy. So that losses reduce the flow rate lah. Okay. So when you consider the losses inside the pump, so brake horsepower, W shaft plus losses. Okay, so that one is brake PHP. Okay, so because of the losses, so normally when you calculate the work by water horsepower, oh silap, this is horsepower, water horsepower. So the water, when you have the losses, of course you need to supply more. So means that it should be including the losses. So first, this is your flow rate, actual flow rate, and after you obtain the flow rate, you know that there is a extra factor for the power, which is you need to consider the losses. So in order to counter these losses, so you have to supply a higher power. So we call it brake horsepower. Okay. So brake horsepower is you supply more in order to counter the losses. So this is the pump. This is the power that supplied by pump lah. W water horsepower. But for the electric go to mechanical. So your mechanical is HP must be higher in order to counter the losses. Okay. Boleh So the relation between water horsepower dengan shaft will be represented by efficiency of pump. Efficiency of pump. If your efficiency of pump equal to 100%, means that no losses. Tak ada loss. If you have efficiency of 0.8 for example ataupun 80%, so you have 20% losses. You have 20% losses. Okay. So the difference is BHP is the power needed to supply to the pump in order to deliver this flow rate, plus in order to counter the losses. Okay. And then another term is EGL, energy grade line. It's the same. Cuma beza dia adalah macam reference point lah. Reference point. Okay, reference point. So before I go further, this is, we call it manometer. Manometer. What is the purpose of manometer? To measure the height. This is you want to measure the height. Okay, if you see here, this is the difference in the height. So like you learn in the school time, so you have a P equal to rho G H. Okay, this is the difference in the H represent to the difference in the pressure lah. Okay, so I guess we need to go later on to the calculation, and then you will understand better lah. Okay, so for the pump, you need to know three things. I recap back. The first one is water horsepower, and then the second one is brake horsepower, and the last one is pump efficiency lah. And before that, you need to know the fundamental aspect lah, which is flow rate, mass flow rate, volume flow rate, and also the Bernoulli equation. Okay, so right now, the one that we discuss right now is regarding the pump only. Row at point 1 and at point 2. It is not included the system. Not included the system yet. Okay, this is the inside inlet and outlet of the pump. Analysis of the pump. Okay. So for the pump,